Welcome back, students. In this module, we are continuing with the problems on types of discontinuity. What does a question say? You have a function. What to do in that case? Here we have to discuss the continuity of f of x at which point x is equal to 0. So we can say a function will be continuous at x equal to 0 if and only if limit x is tending towards 0 f of x should be equal to f of x at x equal to 0. From the question, we already have the value. The f of x at x equal to 0 is nothing but e square. So, as we require f of x when x is tending towards 0, from the question, its equation is e raised to 2x minus 1 into tan x upon x sin x. What to do in this case? Multiply and divide by x square. You already know this. So, as we do it, e raised to 2x minus 1 upon tan x, the whole upon x square. The whole upon x sin x upon x square. Now, in this case, that x square in the numerator, that is, over there, x square, it would get splitted up into e raised to 2x minus 1 upon x and tan x upon x. And in the denominator, x and x square gets cancelled. So, your equation would be limit x is tending towards 0, multiply and divide by 2. But why? Since it is e raised to 2x. So, for balancing the coefficient. So, e raised to 2x minus 1 upon 2x into 2 into tan x by x, the whole upon sin x by x. In this case, what would the equation be now? You already know the standard forms, dear. What is it? Limit x is tending towards 0, e raised to 2x minus 1 upon 2x. It is a which standard form? It's a standard form of limit x is tending towards 0, e raised to x minus 1 upon x is 1. So here you would get 1 into, you also know that tan x by x is 1. So you would get again 1, the whole upon. You also know x is tending towards 0, sin x by x is 1. Hence the value would be 2. In this case, I can say the function of f of x when x is tending towards 0 is nothing but 2. You remembered something? What is it? F of x is discontinuous at x equal to 0. The only reason is that x is tending towards 0 f of x is not equal to f of x at x equal to 0. Why? Because the answer which we have got is 2 and the f of x in the question is e square. So in this case, what to do? It can be made continuous. How? By redefining the function. How it can be redefined? The f of x should be equal to e raised to 2x minus 1 into tan x upon x sin x, and mark this value at x equal to 0, function would be 2 and not e square. Such type of problems you can expect in the examinations. Moving ahead with the next question. You have a function. Here we have to discuss the continuity at which point x equal to 2. So a function will be continuous at x equal to 2 if and only if x is tending towards t minus f of x should be equal to x is tending towards 2 plus f of x. In this case, we already have the value for f tending towards 2 minus should be equal to this as x square minus x minus 1. Substitute x as 2. Why is it so? For continuity at which point x equal to 2. So hence, substitute x as 2. Your equation would be 2 square minus 2 minus 1 and which is equal to 4 minus 2 minus 1 whose answer is 1. Moving ahead with it, therefore I can say limit f of x when x is tending towards 2 minus is nothing but 1. We also know limit f of x tending towards 2 minus should be equal to 2 plus f of x. But in this case, for 2 plus, the function is 4x plus 1. When x is 2, the value would be 9. Students, you already know the formula now. You have seen various concepts. In this case, the left hand limit is 1 and the right hand is 9. So, what is the conclusion? You remember this. Here, f of x is discontinuous. Absolutely fine. But when the left hand limit and the right hand, they are not equal, they are irremovable discontinuity. So in this case, since f of x is not equal to, that is the left hand limit is not equal to the right hand limit, in this case I can say that hence f of x does not exist and such type of discontinuity cannot be removed. Students, solve some more problems of such types. Till then, see you. Thank you.